Time for some more kitchen table astronomy with Hampshire College astronomer and the head of Kainaat Studios, Mr. Universe, Salman Hameed. Quick movie review. F1, no. Superman, yes.
Yes, exactly. I actually took a short nap in F1 because it was just the 60% of the time was just these races. But then went to see Superman with my 12-year-old and granted with a little bit low expectations, but it turned out to be great. And I know there is controversy about
woke Superman,
immigrant, and all of that stuff, which is correct. But it has. I mean, it's a light movie. It's not sort of a super commentary on it or Watchmen, which great comic.
Love Watchmen.
And the series was also good. Movie was okay, but yeah, I thoroughly enjoyed Superman. So if you get a chance, go see it. I saw it in XD. Not at Emmer Cinema,
where you were a board member.
Yes, but no, it was a lot of fun. I think that's a nice summer movie.
Meanwhile, speaking of aliens from other planets or other solar systems, that is exactly what is happening right now. We have an alien comet coming into our solar system.
Right. So this is really cool. Monty, we talked about it quite a bit, couple of years, and then the first interstellar object passed through our solar system. It was called ʻOumuamua. That was in 2017, and that made a lot of noise because it was like, whoa, it's not from our solar system and it's passing by. And at that time, it was on its way out from our solar system that it was caught.
It also didn't hurt that Avi Loeb, the famous Harvard astrophysicist, said that ʻOumuamua was probably leftover alien tech without any real solid evidence for that kind of huge claim.
I'm not even sure how much probably was in there because I think because he then wrote a full book about it,
which I read, and it's got a lot of interesting points, but is also a lot of eye rolls.
Right, and it was a New York Times bestseller. But again, and that is one of the reasons the later discoveries of other objects are crucial for that. So
because rewind, we know that other things from other solar systems must have passed through our solar system, but it was just recently that we finally had enough scientific technology and evidence to say, hey, we found one. And since then, we found others.
Right. So there is stuff between stars as well. We know that. And our solar system is going around the galaxy. Our galaxy has a few 100 billion stars. Our sun is just one of them. And in our own solar system, we know that we have planets. We have asteroids, we have comets, and some of the comets are way out in the outskirts of our solar system, extending almost a light year away. In fact, people talk about we don't exactly know that maybe the outer part of our solar system where the comets reside, it's called the Oort cloud, that maybe our Oort cloud almost extends and connects with or touches, for example, the Oort cloud of the Centauri system, the nearest star system, which is 4 light years away. We don't know because it's hard to see those objects. Those are ice balls. When they are way out, they don't emit much light, but we see them when they come close to the to the sun, and we see them sort of their ices starting to evaporate and they turn into a tail, and we say, oh, that's a comet. So you can imagine these kind of objects being chucked out from our solar system. By various interactions through a big planet, Jupiter, or small planets, their orbits can change, which we also know that happens. Some of them, in fact, can be thrown inwards as well. That's how we know that comets come from sometimes only once. They're coming from way out of the solar system, but their orbits got disturbed. And then they come to the inner solar system. And so you can imagine their orbits being disturbed in a way that they get chucked out of our solar system as well, and then they will be in between the space between stars. But there are also ways we know that sometimes there are rogue planets without star systems. You can actually form planets without star systems. You can form these kind of objects in gas clouds without a star system. So the idea that there would be stuff between stars is actually quite reasonable. The question was, as our solar system goes through, as our sun is orbiting the galaxy, would occasionally some of that stuff is going to pass through our solar system or not? And the likelihood was like, yeah, it does. The question is, how do we find them and how do we detect them? And so that's how we found the first one, ʻOumuamua, which was in 2017. ʻOumuamua is means scout, I think in Native Hawaiian. And then Borisov was discovered in 2019, named after an amateur astronomer that discovered it in Crimea. And now the third one has just been detected on July 1st. It is named 3I Atlas. And
Ooh,
Atlas
I kind of like that name, 3I Atlas. It sounds like a movie.
I is actually the third interstellar object. So it was 1I, 2I Borisov, and now it's 3I Atlas. And Atlas is the telescope system that detected it. It's called...
Not the farm stand on Route 5 and 10. They didn't name it after that?
I don't know. No comment on that. But it is called Asteroid Terrestrial Impact Last Alert System. So Atlas. And so it's
Wait a minute.
Hold on. It's detecting potentially threatening asteroids. That is their job. But no. I mean, so
This one is non-threatening?
You would have found out if it was threatening, because they would have sort of not just said, hey, isn't it really cool? And rather it would be like, hey, run. This is coming towards
Where would we
us."
run?
So how the question is, how do we know that this is an interstellar comet versus things that come from the Oort cloud, I was saying, from the outer parts of the solar system, or any other things? And that has to do with their speed and the orbit that they are taking. And
Which is, goes it back to Oumuamua, it started to speed up in a way that made Avi Loeb and other astronomers be like, hey, maybe it turned the gas on and started to speed away. There are other explanations for this, but it was an interesting aspect of that interstellar discovery.
right, I mean, so let's be clear. That is a strange object, because we have never seen, I mean, at that time in particular, we had never seen an interstellar comet or an object, whatever it was, coming through. And so we're trying to figure out what is happening and whether that same kind of properties are going to be with other objects or not. Mm-hmm. So at a particular time, we would expect actually many objects passing through our solar system. The question is, can we detect them or not, right? And so it did speed up a little unusually, and people think, and people who are not named Avi Loeb thinks that, well, there may have been a slightly comet outgassing, like, that you have a little bit of gases that can give it a little push. Probably that's what may have happened. But again, just because we don't understand something doesn't mean that it is an alien spacecraft.
Right.
The burden of proof regarding that kind of claim has to be on showing that it's an alien spacecraft, not that, hey, this is a little weird, we don't know what is happening, and hence it's an alien spacecraft. So I think there is this arrow problem that goes in. But in this one, 3I Atlas, let me just set it stage why immediately they were like, oh, that's sort of like, an object from another star system. And that is because it is traveling really fast. It's traveling about 60 kilometers per second. Okay, so it's actually really fast. And it has what astronomers call, you can think of how its orbit is. So if the orbit is perfectly circular, that we call it sort of like the term, we call it eccentricity. I mean, Monty, you have a very high eccentricity.
Yes, right. I may not be going that fast, except if I'm trying to drive to the Cape in the middle of the night.
But for a circle, the eccentricity is 0. It's a perfectly round, And for an ellipse, as you flatten it out, the eccentricity becomes the higher values, but it stays within 1, which means that it is still bound gravitationally, right?
Okay.
So between 0 and 1. At 1, you have a parabola, which means that it's just enough to keep on going up, but it's kind of a little bound in some way. So it's just 1. Now, more than 1, this is the eccentricity on how the orbit is. If you have a value of more than 1, that means that you are in hyperbolic or hyperbola, meaning to say that you are not bound gravitationally, you will just keep on going.
I'm also very hyperbolic.
Exactly, that's what I mean. Your eccentricity is very high. And so ʻOumuamua was a little over 1, its eccentricity. Borisov was about 3. So that means that's the reason why we knew that it was not bound to our solar system, but it's passing by. And this object, 3I Atlas, has an eccentricity of over 6.
Whoa!
And so, again, not knowing any values or things like that. But what that means is that it is not even it's really doing sort of like, pass by. In fact, its orbit, the way it's coming in, it's going to be passing close to Mars. That's the closest it's going to get. And then it doesn't even come that much close to the sun. It just orbits, it tilts a little bit toward its orbit towards the sun because of its gravity, but it's going so fast, keep on going on its way out. So it's just basically passing by, no stop, no pit stop here. And we have detected it. And this is the cool part. This comet coming in on its way towards the inner part of the solar system. ʻOumuamua, for example, was moving away from us, so it was hard to detect. This was detected when it was somewhere on the distance of Jupiter, and now it's coming towards the solar system, to the inner part of the solar system. It's going to be closest to the sun in September. And then Mars, there are spacecrafts over there that can actually take its pictures, because when it's closest to us and the sun, it's towards the side of the sun, and we can't see it.
So we won't be able to see this one with the naked eye.
Probably not, but unless it gets really bright as a comet. But there are spacecrafts on Mars that can actually take its pictures, and maybe one of the spacecrafts going to Jupiter also may turn around and take its pictures. So we may actually, because we know it already has a comet-like features, much more than Oumuamua. Oumuamua was much more rocky, but it was a comet, we know, but more or less a rocky thing. But here we know that it has enough material on it, and we think it may develop a tail. We don't know, but it's moving in this direction. So right now, I just recently checked, it's about 450, 500 million miles from us, but it's coming close. It's going to pass by Mars. That will be when it will be closest, and then it will keep on going. We will be able to see it again when it's away from the sun for us, and that will be in December. And then we will see what happens. But it's kind of cool. I mean, here we are. We cannot go to other star systems
Yet.
and we cannot go to interstellar space
Yet.
But
Unless you're Christopher Nolan.
that is Christopher. No, oh, that's correct. You mean with a wormhole? Yes.
Yeah.
But we can take samples in some ways, or we can observe an interstellar object like this coming from interstellar space. So that's actually kind of cool. And so yeah, so that's, I mean, again, from a larger perspective, this is an amazing thing that we have telescopes that can actually identify objects. Then you go like, okay, you can actually see them move with respect to the background stars. So not only we can figure out that, hey, here is that little tiny dot that we are observing, and it is moving with respect to background stars, and it must be, we can figure out its distance, so it must be a asteroid or a comet. But then we can also say, you know what? This asteroid or comet actually came from this direction, and it is actually not part of our solar system. It is just passing by, and that I think is really cool, because we can get so much information just from these dots moving in our observations from the telescopes.
It is pretty cool. 3-Eye Atlas, right?
3-Eye Atlas, it's a guest. Treat it nicely if you run into it. Do not put it in a detention center. It's just passing by. It's on a tourist visa.